Okay, we're going to add some lighting to the game. Well, we're going to progress as much as we can toward adding a new type of lighting to the game. Point lights, it's going to be a very, point lights are a very simple, very traditional form of lighting, and we don't even really have it. So what you see here, so this is a scene in the editor for the game. You know, I can grab stuff and move it around and all that. So if we were to add lights, this is where I would do it if there were static lights in the scene. There's basically two kinds of lighting going on here. We have sunlight, which is directional, right? And it's, these little streaky guys are showing the direction of the sunlight, really. Except they're a little buggy under some circumstances. I mean, this is fine for now because the camera doesn't move, but it's not very controllable. So we need to debug that at some point. But anyway, so we have the sunlight. So, you see the sunlight and the shadow map and all that there. And that's great. The other kind of lighting that we have in the scene is precomputed illumination that happens when we run a light mapper on it. So, here, like we have sort of an invisible emissive object in here, and then the light mapper runs and it sort of shines the light out on there. And, the sunlight hits here, and then we sort of get bounce illumination. Okay, here we go. So this is the light mapper output. And then these green pixels are just sort of like, I think, unset pixels that we're going to have to clean up at some point. But this is sort of the bounce light for the entire scene, right? Now, the thing about bounce light like this, first of all, it's static and it's baked in to the entire scene. And secondly, it doesn't have certain things to it. Like it's purely diffuse lighting, right? There's no specular component to this. And so it's a little more like quiet than light usually is under some circumstances, right? Is it the same as the light mapper detailed on the witness blog? Yes, basically. There are probably some minor differences. So, that's what we've been getting by with, and we can make pretty okay looking scenes, right? But we want some dramatic lighting that like lives in the levels, and we want to be able to have effects. So like if somebody teleports, we could like have a flash that lights the level and all that. And these are going to be relatively expensive effects. So when it comes to the directional sunlight here, when we generate the shadow map, I wonder if I can find. Can I find shadow map debug mode? Do we even have it anymore? I don't know where it is. Anyway, there's some key that'll draw the shadow map. But anyway, that gets drawn by a single projection, right? So you render a scene from the point of view of the sun direction, and you set up an orthogonal matrix, and you make an image where each pixel contains like the depth from the direction of the sun. And then when you render, you basically sample that image for every point in the scene, and you do a depth compare to decide if it's in shadow or not, right? Now, the reason you can get away with a single image is because the sun light is parallel, so it all projects onto one plane. But if you have a point light in the middle of a scene, you have to think about it casting rays in all directions, right? And so it's not, you don't get off so easily as just making a single quad, right, with a shadow map on it. If we want to do a full solution, sort of the cheapest way that I know of these days is to do a cube map where you actually render the scene 6 times from the point of view of the point light and do that kind of, depth mapping 6 times there, right? We're not going to do all this tonight. We'll be happy if we can even just get point lights going at all. Clearly, I'm a little bit, you know, my explanatory brain sometimes is turned on and does a really good job explaining things. So far tonight, it hasn't been turned on, and this has not been a very good explanation. But like, are there any questions with what I said so far? Does any of that make any sense to anybody? Yeah, somebody's put a link here about shadow mapping. Use a frag shader and only render it 3 times. How would that work? Do you mean like rendering 2 planes of the cube at once, like 2 neighboring things, or do you mean opposite sides of the cube? I guess you could do opposite sides of the cube and like, I mean, you could. How will the light interact with the shadow map? Well, I mean, what you do is you have a separate shadow map per light source, right? And that shadow map just says either the light source reaches this pixel or it doesn't, with a little bit of filtering. So you'll see here, you know, like where the sun hits this, there's a little bit of filtering happening. So yeah. You transform the world non-linearly to a shape that the cube can rasterize into only one image instead of just a plane. Yeah, so I see what you're saying. But kind of what I'm saying is, if you don't backface cull, or like here's a thing about rendering, right? Usually we cull things that are behind the near plane, right? Because when they're behind you, they would like project upside down and whatever the hell, right? But if you actually, yeah, that wouldn't work. I don't know. I'm almost thinking that you could render opposite sides of the cube at the same time into one projection, and then you don't have to do any nonlinearities. It might not quite work, actually. Anyway, we're not even worrying about that right now. What about a geometry shader? You are still rendering 6 times, but on a single pass, maybe faster. Yeah, I mean, all that kind of question, how to optimize that, we can visit later. Like the question initially is just making it work, right? I mean, this game has to run on multiple different rendering APIs by the time it's done anyway, and different things are done differently on different APIs. How much cheaper are shadow maps than calculations for shadows on dynamic objects, like the pawns or the block? I don't know. What do you mean calculations for shadows on dynamic objects? This shadow map is being rendered every frame. It's fully dynamic. There's an optimization you can do where you like render all the static stuff to one shadow map, and then you render all the dynamic stuff to another shadow map, and then maybe you combine them, or you just use them both when you sample. You could do that, but you know, we don't bother right now, simply because, I mean, if you have animated stuff, I don't know, it might be worth doing eventually. In the witness, I think we did something like that to avoid draw calls. Future APIs, or current APIs, make draw calls less expensive, so that's less critical to do, although it's may still be a good idea. But for us, if we're going to have like a lot of animated plants, then the amount of benefit that we would get from such a technique would be decreased substantially. You guess the Entity Explainer stream got put on the shelf for later? Yeah, you know, I just decided to do other stuff this week. Like I wanted to make some levels and whatever. So, you know, it is what it is. Could avoid actual rendering if you do that, not just draw calls. Yeah, I mean, you know, but that kind of optimization, I think, is best done once we have all the effects that we want and they're put together and we're getting the scenes that we want, because then we can actually profile and say what's taking how much time in these scenes, right? I do suspect that if I do these point lights the naive way, that they will be something that we'll want to speed up. But it's always good to like see the problem relative to the other problems you have. Okay, so we have shaders. We have all kinds of material shaders, and they all call, I think, some set of stuff here in material.glh. The question is, are these the right functions? I'm not sure. So these functions, they're a little bit annoying. They have a lot of like copy and paste between them. I guess that happens if you don't really trust the optimizer or something. But anyway, I want to know, so I think shaded here is the main thing that we use, but I'm not sure. So the way that I'm going to do this, we're sort of doing shader archaeology right now. I'm just going to set the color down here. So we do all this stuff where we say diffuse color is, well, we're dot producting it with a light source, which is going to be the sun. And I guess there's some kind of like Fresnel, or I don't know. So I could change the diffuse color. I could say diffuse color dot RGB is VEC3100. I don't even remember GLSL, so I don't know if that's a valid thing to say. So we're gonna have some amusing time. So now we're like recompiling a billion shaders, as you can see in this window. Compiling shaders is really slow. Wow, this is going to be a lot more annoying than I thought. Like, we're literally rebuilding every single shader, not just the ones that we're using. This is the kind of thing that I got really frustrated with toward the end of the witness. So I think we're going to have to speed that up. Okay, so we changed all those, and our scene was not affected, which is a bummer. So I have to keep doing this until I find the thing. Let's do this, right? Gonna put that, because the thing is, we've gone, as we develop our art style and develop materials, we've gone through using several different materials. So I don't actually know which ones are being used, really. So we're going to do both of these, and then we're going to wait 10 million years while we're... This has to get fixed. This has to get fixed. This is ridiculous. I have a way lower tolerance for this kind of thing than apparently other people do. I would not live with this for one day if I was working on shaders. I don't know how people do it. All right. So that didn't do it either. So we have these Pbr materials. Maybe we're using these now. I don't actually know. So let's try Pbr shaded. And maybe we'll recompile fewer things. How much could you speed up the shader compilation? Well, the actual compilation of individual shaders, maybe not very much, because like we just give it to the OpenGL driver. It's one of the nasty things about OpenGL. But I don't think we're using all these shaders in this scene. So what we could do is just mark the shaders dirty and only recompile the ones like as a, hey, we got it. Okay. This is good. This is not all of the materials, but it's most of them. So let me get rid of these. So then Pbr, there's Pbr Mat. So let's try this. Let's make this green and see if we get, we're still loading. See, now if I resave this while we're loading, I don't know if we're going to get everything again. All right. Wait, why? Now we got everything except the water. Huh. Okay. Let me try this. I'm going to put the green in. You know what I should have done? Because I think there's one or two other shaders. Pbr Mat. Nope. So we might be able to delete all these old shaders at some point. Didn't do it. Well, who knows what those use. It doesn't matter. For like implementing lights, this is good enough because it's basically the whole scene, right? And then we just make sure that the call to add lighting is used in every frickin' shader. Okay. So let's take this out. So now here's the question. So we have this, which I guess is modeled after the Unreal Pbr thing. It's actually a really simple function because all of this is commented out. Well, these are calls to other things. So the one question that I have right now is like, what space is this stuff in? Like it doesn't say is the light vector in like world space, or is it in the mesh space? I don't frickin' actually know. I could find out though. And we could find out by doing more shader archaeology. Okay, so for example, what happens if I say sun direction? What's the first use of sun direction? I'm just going to make it up. Uh-oh. Oh, it's vec3, not v3. Assignment to uniform sun direction, right? See, I don't know the rules of GLSL, so. Oh my God, dude. Maybe we do use all these shaders in this level. I mean, I believe many of them. Oh no, we don't use all those. All right. Why is that still red? Like, what? There's some bug where those guys are delayed by one reload, because I think they'll fix themselves after we keep editing it. Anyway, okay, so now let me just see what happens, because we changed. Let me open the color panel so that the selection goes away and I can see the guy. So it's hard to pick out the difference between the shadows and the, so here you could see, you can see it's definitely coming from the Z. Right now the Z direction in model space and the Z direction in world space for this guy are the same, right? And so the shading is on the underside of his boobs or whatever, but that's consistent for both. And now the thing is, as I turn it this way, wait, is that? Yeah. Now the problem is, here, let's make this guy inanimate. So the problem is, while he's a character, he's being snapped, but inanimates are free, well, we are free to have this set. There we go. So it seems like he's still being lit in world space. Like the light direction is literally upward in world space. It's not in his model space. See what I'm saying? Which surprises me. I expected it to be transformed to the dude's space. Because like if you're actually in world space, after some coordinate magnitude, you start having floating point problems. That's not a level of coordinates that we'll ever have in this game. Like once you start going around 1,000 or 2,000 in X, Y, or Z, you maybe start having problems if you're not careful. But this sure looks like it's in world space, which is easy. It means we don't have to do as much work on the CPU, because if we decide where the light sources are in the scene, then we just, yeah. All right, so this is good. So I notice that, I think it was Ignacio, somebody, probably him, because I think he wrote most of this code, put in a placeholder for information about lights. So if I go to shader globals, right, we have this thing called level parameters, which gets uploaded. It currently gets refreshed once per frame. We could refresh it less, but it has this thing called point lights, and he has an array of 127 point lights, which is probably more than I would have done, but maybe he was thinking that each entity would know some indices of which lights apply to it or something. The old school way to do this would be to just change the lights per entity. But maybe that's just more data going to the GPU than doing it this way. Anyway, so there's this point light info, and it's not being used in the program anywhere. So it's a placeholder right now, and I think we're going to start filling it out and start using it. Position, radius, we're going to have a color, right? And vector 4. And this is going to be pre-multiplied by a magnitude of the light. And then that's probably all that we need initially. So these will get sent to the GPU every frame. We don't need these semicolons, I don't think. I think. Don't even know my own programming language. So then if you wanted to animate this color, for example, you wanted a light that was strobing or anything like that, then you just poke a different value in here. So what I'm going to do just to get these booted up is I'm going to pick some coordinates that are like in the scene. So like this rock is at 4, 1, 0. So I'm going to put a point light at like 5, 2, 2, right? So how do we do that? Well, what did I edit in this file? Oh, the semicolons. So here we have some function called refresh. Here we go. What is it called? Refresh global parameters. And here we're just doing a bunch of stuff that we do once per frame. And so we do global parameters, but then we do level parameters. And right now, I'm just going to hard code one light source in it. I'm going to say point lights, ligets. It's like Knigets from Monty Python and the Holy Grail. I'm going to put it in a block here, and I'm going to say light is level parameters dot, what was it called? I'm just going to paste this over here so I know what to set. Oh, it wasn't shader globals. Level parameters dot point lights. So we're taking the pointer to the first point light. We're just going to hard code it, right? We're going to say light dot position is v3.522, right? Light dot radius is, oh, we want more. Okay. This is not quite enough because, well, I'm not sure. I'm not exactly sure what we want. See, I think for nicely controlled point lights, like, okay, remember how I said we're going to have a cube map that does shadows, right? The thing is, because these rays are going out from each other, out from the point, if you go very far back from the light and you still have a very strong shadow cast, then you'll get very low sampling on the cube map and you'll be sad, right? You'll just see giant chunky pixels. So, well, and giant chunky pixels that are not very coherent over time, so it'll look terrible even if you try to filter it. So what we tend to do is have some way of filtering it to zero contribution before it gets bad, which is not really the way that light works in real life. You know, a point light actually casts its light quite far in real life. For example, the sun is a point light. I mean, it's not a point light in our rendering, and it's not effectively a point light on planet Earth just because the sun is so far away that its rays essentially come in infinitesimally close to parallel, right? But it's actually a point light out in space, right? And the light still gets here. But if this were a video game, we would be worried about shadow casting at 8 light minute kind of distances. Someone's saying no high dynamic range. What do you mean? No, we're totally high dynamic range. What are you talking about? So anyway, but I think we maybe want 2 radii, kind of like you tend to do with sound effects, like an inner radius, and once, like, you just have normal, regular light behavior out to the inner radius, and then between the inner and outer radius, you have a fall off, right? So I'm going to do that. I'm going to go inner radius and outer radius, distance at which we start attenuating the light, distance at which the light's contribution is 0. All right? And then we have a color. And yeah, I'm not totally sure. Well, okay. So light fall off can happen naturally. Oh, I mean, at HDR, okay. At HDR, yes, your light will contribute things for a very long way. Yes. But like I said, you get this big chunky pixel problem after some distance. So you would prefer not to use these radii, all right? But sometimes you have to, right? Sometimes it's better. And if you're in a scene like that one that we were looking at that has light in it anyway, then at some point the additional light's contribution is going to kind of get blended into the other light sources, and it's not so bad. But it's still HDR even if you multiply it down to 0, because the magnitude of the light has the correct gamma and is high in magnitude, so you can like bloom it and whatever. Point lights are overrated, line lights are better. We may have line lights eventually in this game. We have good reasons to have line lights, as you'll know if you've seen some levels, but that's not what we're working on right now. Okay. So we have this situation. Now, we're going to go inner radius, and we're going to make it kind of small just so we could test, right? Because this might look bad, what we're doing here. Who knows? Outer radius is going to be 8, so it's going to fall off quite quickly. Outner, not outner. Outer radius. And brightness, I don't know what our brightness scale is right now. I think like 25 is probably pretty bright. Light dot color is V4. Let's make it a purple light. And then I don't know what alpha is going to be used for, but we might use that for something. So we're just going to put an alpha, but it's just going to be 1. All right. So we're going to do that, and we're just going to compile it, and it will do nothing. Uh-oh. Color is not aligned properly. OK. Well, I lied when I said it would do nothing. I guess we don't worry. OK. So this is going to be 4 things, right? And that's going to be 4 things. And then that's going to be, I think that might work. All right. Cool. that was not our programming languages. That was the GL code complaining, because when it uploads stuff to the GPU, it wants it aligned in a certain way. Bro, what is going on? We've also got, like, our startup time has gotten so slow again. Like, it's driving me nuts. Like, we literally are taking 25 seconds to start. All right. Oh, I think my light direction is still hard-coded to Z. Unfortunately, we can take that out. Okay, so we're still running a scene, you know, like no harm, no foul. We didn't break anything. So let's change underscore sun direction back to sun direction, because that experiment is complete. Actually, we might bring this back at some point. All right, so let's see what, so we want to do essentially whatever this is doing, but for a point light. So, like, essentially, we need to figure out what are the coordinates of our current pixel. So let's see. See what we have. Oh, oh, nope, this was regenerated. Okay, so here's a cool thing that you can't currently do in C++, right? I changed those data structures in the language, right? In our equivalent of C++, right? And at startup, we introspect our data structures and output them in GLSL. So you notice this has inner radius and outer radius now in the order at which I put them. It's because we look at those data structures and generate this output. So I don't have to remember, because I did forget to look at this, but I don't have to remember because we do it for us. So that's nice. It's way less hassle. And we can do that with, you know, shader uniforms and all that sort of stuff. It's good. It's a good action. You don't have to worry about accidentally misspelling one of them. Okay. So what is the output of our vertex shader? That's what I want to know. Okay, this is all stuff that the game tells us. What file were we just looking at? Material. Like, where does this do? Diffuse color is fragment shader. Okay, so we have vertex shader.glh. So vertex position. Okay. We have a thing called So I wrote all this stuff originally. This com thing means it's out from the vertex shader and it's in for the fragment shader, so we only have to declare it once. It's just been so long since I've done this. What does that actually mean? So we just use those variables. Even though it's in a pixel, we just say vertex normal. It means the thing sent to us from the vertex shader. Okay. So now what? Well, we start doing this thing. So we go to Pbr here, and we're going to start stupid, right? So we're going to say point light output equals, damn, what, shader, no. I was just looking at this file, globals, all right. So we want to look at, I think we can just say point lights sub 0. So can I say RGB in OpenGL? Can I do that? We don't have a shading flag for this. Okay, so we're going to do this, and then we're going to say plus point light output. Now this is still not a point light. It's just going to add the color passed in from here, which could be, now we'll wait for that to compile. Did we take out our, yeah, our sun vector? Yeah, we did. All right, let's see what happens. Dude, I hope you're not saying that milk frother is a sign of being in a cult, because I have a milk frother. Okay, there we go. It's a purple light that's very intense. And we're just adding it to every pixel indiscriminately, right? So now, well, we could say vec3 point light direction equals, I don't know, like, do you say normalize? Help me out here. We're going to say it's normalize of vertex position minus point lights 0 dot position, right? Let's see if that complains. No, oh, it knows normalize. Okay, good. Good. I am the cult leader in this scenario. Okay, well, that's good. We know where we stand. Second day of university. Where are you going to school and for what? I mean, if it's the second day, you might change your mind, right? That's how it goes. But where are you at? What does vertex position represent? I believe it's the position in world space, but we're going to find out. Because if we're wrong, then we'll be sad. Okay, so here, so we're going to say vec3 point light dot is minus, okay, wait. Let's go this way. We're going to say point light's position minus vertex position. So it's pointing at the light source from the vertex. And then we say it's the dot product vector normal, or vertex normal, sorry, with point light direction. And how do you clamp? That's a float, sorry. Saturate, is it that? We're just winging it, man. Does someone else saturate here? Oh, saturate doesn't take parameters. Okay. All right, let's see what happens there. Oh, it doesn't like it. Undefined variable dot product is probably just dot, right? Okay, good. See, this is what happens when you don't know a shader language. It's basically the same as every other programming language, so it doesn't matter. Okay. Like you can just use clamp. Well, but I just want it 0 to 1. As long as saturate does 0 to 1, it's fine. That's all we care about right now. Okay, great. So we're still compiling. We're not using this point light dot yet. So now let's say this times point light dot. And we'll see what happens when that is finished. It might be totally nonsense. The high probability outcome is a totally nonsensical result because that's just what happens when you're graphics programming and you make assumptions like that this is all in world space or that you know how to program. So we'll see what happens. Okay. I mean, it's definitely something like, but it doesn't look all that different from when we just added to everything, which is weird. So if this is actually working in world space, no, see, here's the thing. Okay, there we go. So stuff, does saturate go like -1 to 1 or something? Like, what does it do? I am generally seeing kind of what I expect. Maybe it's just way too damn bright. Like, see stuff facing away is going to 0 like I would expect. Let's turn it way down. Let's just see what happens there. Pretty sure it's 0 to 1. Suppose it's literally free on a lot of hardware. Yeah. Okay. See? Okay, this is kind of making some sense now. So you can sort of imagine. Yeah, see, if there was a light source right here where we said we were going to put one, then this would be away from the light source. And so would that. And then you would say, but wait, why is this rock on the back side getting shined on? And the answer is because we don't have that shadow cube that we were talking about. So this little rock down here, let me go to the editor. Oh boy, look at our purple light. Like this rock down here, hopefully you can see the cursor, all these rocks, they don't know that these rocks are here, right? So for all they could tell, these aren't here and the sun is just shining down on them. So that result makes sense. Even though this looks like kind of garbage, this is actually what you get when you don't have shadows. So let's, it's still way too intensely bright. Oh, we're not attenuating by distance, by the way, guys. So let's do that. How could I forget that? Do we have a distance function? Yes. Okay. So we take that distance, and we're just going to say, instead of 0.05, divided by point light distance times point light distance. Actually, see, this is stupid because distance does a square root and then we're squaring, right? So what you really want to do is take this delta and dot it with itself, and that gives you the distance squared. And we'll do that in a minute once we get a sensible result out of this. Boy, this stream would be more fun if we didn't have to compile a million shaders all the time. I was like, wow, it's still very bright. Oh yeah, because we don't attenuate. Okay, so now you can sort of see it's hellishly bright in the middle, and then it's sort of falling off. Like, it's still very bright toward the sides, but like not that bright, right? So that's cool. So let's take it down. I mean, again, we could break and recompile the game, but for now we're going to put a hack factor in here. We'll put our 0.05 back. That might be too dim. We'll see. In HDR, things don't dim that fast. So like 0.05 of a bright light is still not that dim, honestly. I'm going to start heating up some more water. Okay. I mean, that's almost not totally unreasonable. Like, we could almost start using this in the game if we wanted to. You know what I'm saying? Okay. We're not using these radii yet. Okay, here's a thing. Well, okay, let me do the fast distance first, and then we'll start using the radii. Yeah. So, right, so we're going to say vec3 point light delta is just this. It's going to be this, right? And then we're going to say normalize point light delta, and we're going to say distance squared is dot point light delta with itself, right? This is just something anyone who's ever optimized games knows this, right? So then we just go divided by point light delta, and there we go. So this is distance squared, and then we divide by distance squared to attenuate by r squared. And we made a mistake. Point oit delta. Oit. Oit. All right. So next is going to come the fun part, right? Because so far this has been a crappy shader hack. But I guess the next thing is to hook it up to the editor. Why is my laptop? Oh, my laptop must be waking up to reboot to install updates. That's why it's available for streaming. Ooh. Yeah. Okay. I said it was squared distance, but it's a little bit of a lie. Wait, no, that should have worked. What happened? What did I do? So this is cool. This is like if we were making an 80s game, like Blood Tiger or whatever. But this is not actually what we wanted. And what's happening is on the right-hand side, we have like a negative. We're like going past 0 or frickin' something. I don't know what we're doing. Let's fly around. Isn't that cool? Look at that. Like, why is that aligned with the y-axis? What mistake could I make that literally aligns us with the y-axis? I'm dividing by a vec3. Oh. Yes. Remember when I said this cool trick that everyone who optimizes games knows? It's not that, it's that. All right, thank you. Okay. Well, this is much more sensible again. Like, that looks kind of cool, man. I dig it. It doesn't have shadows, but I dig it. We're going to have a good stream tonight. We're just getting going. All right, so now the next thing is we're going to do this incrementally, right? The next thing is to drive this from some kind of actual entities in the game, right? So now one kind is a static light. So we're going to want the ability to, like, position a light around in the world. That'll involve making a new entity type, and then the light comes out of that entity type, right? The other will be dynamic things, right? So if an effect happens, we want, dynamic lights and stuff. Now, in this function over here, where we, where was it? Shader globals, right? Refresh, flow. Is that in draw? Yeah. So here, instead of hard coding a point light, we're going to want to go through all the point light entities that are in the game and copy the data over. However, one step at a time, right? Incremental progress in game development. So I'm not going to, the fun thing I'm going to do is I'm not actually going to make a light entity first yet. I'm going to instead iterate over the world and look for something and fill in lights. And what is that something that I'm going to look for? I think it's the character. Maybe we'll do these two, because that might be fun. But for now, we only have one point light. So we're just going to attach this to the character for a second and see what happens. So here's what I'm going to do. I'm going to go light index is 0 for manager by type. Oh, we have an it index. We don't need that. Oh, but maybe we do if we put other stuff. So we're going to go light index. And we're just going to fill out the same parameters. And then we're going to say light index plus equals 1. If light index is greater than or equal to max, point light infos break, right? So what's max point light infos? It's going to be the 127. So we're going to say here, right? Okay. Bam. I never played Blood Dragon. All right. Oh, well, we failed to actually use. See, we looped over the guy, and then we didn't use any of his data. So here we're just going to say it.position. All right. And now we've got a stew going. Oh, it.position is a thing. That's the gameplay position for puzzle logic, which is why it's teleporting from square to square. So we want visual position. Do I know why that value is 127? I don't. I have no idea. Could ask him. All right. So now we've got a stew going. You know what I'm saying? We had 0 point light ability at the start of the stream. And now we have some point light ability. You know what I'm saying? Like maybe we just even put a subtle point light on the active character. You know, not a not a violet one, but like, you know, as you switch around between characters, maybe we do that. That's pretty cool. I'm going to write that on my list. Try point lights for active character. Cool. Make the warriors light red. Yeah, probably. I mean, it's probably each character has a color, so it would probably be kind of white and kind of that character's color, and it would be way more subtle than this. But you can see that we have succeeded. Somehow, even though we're doing graphics programming, we did not flail with a mess for hours. We actually mostly did the thing. Okay, so now, what am I going to do? I'm going to say, I'm going to factor that code that we just did for point lights so that we could have like 4 point lights or something that we actually render. So back in the shader, we are going to do some things, right? We're gonna, so wherever I said point light whatever, I'm gonna say, I'm just gonna hard code it. Like later we might do a loop, whatever. For now, we're just gonna do this expensive, stupid thing, right? And then so the problem is, well, we're going to memset all the point light info to 0. Because we don't want extra little like light turds. If we decide for a while there's 4 lights and then we decide there's 3, we want to make sure the 4th one is cleared out. And if there's 127 of them, then it is what it is. And size up doesn't work that way in this language. All right. So we're setting it to 0. We're going to go here. And then here, we're just going to say vec3 point light output equals evaluate point light 0. We're still not doing this Brdf thing, which we should think about. Let me put that. We totally aren't doing that. We're just doing the dot product. We're just doing the oldest thing in the book. So, and then we're just going to do this. Like that. Okay. So then, whoops, I'm saving this, which, oh, we're not running, so that's fine. We're going to say vec3 evaluate point light. I don't really know what parameters we might need. Is that an int? What? I don't know GLSL. What is it? Okay. Distance squared. Point light dot. Saturate. Point light output. Oh, we're still multiplying by 0.05. Let's do that back here, right? And then let's take out this 0.05. Let's group this. I think the shader compiler probably already does this, but whatever. We're going to group that, return point light output. Okay. Let's see what happens. Probably made a mistake in the shader. That's what happens. Oh yeah, we did. Evaluate point light. What? Evaluate. Evaluate. The stupid computer doesn't even know how to evaluate a point light. Like what? Okay, now I don't even know. Let's try this again. What am I supposed to do? I pay thousands of dollars for this computer. It doesn't even know how to evaluate a point light. I just can't. I can't even. I can't even deal with our load times. We need to do another pass on these. This is crazy. Okay. All right. We have a dude. He's walking around. And now we, in theory, have up to 4 point lights. Okay? So here's what I'm going to do. I'm going to make another loop. We're still not using the outer radius, by the way. Let me put that on the list. I need a better pen than this. This is a terrible pen. I'm going to put outer radius. Okay. So our dude is walking around. Of this little light of mine, I'm gonna let it shine. This little light of mine. Okay, now, whenever we have one of these little crystal cubes, we're gonna also do that. So we're gonna do the same thing here. This is point lights. Let's just say begin point lights and end point lights. All right, so for every rock, we're also going to do this. We're not going to reset light index. We're going to keep adding light indices. We're going to put this at the top, just so we can chain these and we don't have to think about, okay. So we're going to make these like smaller radius and they're dimmer, and it's going to be yellow. All right. And that's basically it. See, you don't need to pay Unity for a game engine to do graphics. Well, maybe you do, because I don't see these lights. Why don't I see these lights? Maybe they're too dim, or maybe they're not there. Let's like not even put the guy in for a second. Maybe you do need to pay Unity for an engine. Like maybe I just can't. I'm still referencing point light 0. Really? Okay, we do have some yellow of some kind. Oh, it's coming from the thing. But yeah, you're right. Like it's only that one. All right. So oh yeah, there we go. Oh, the color. But not the, see, it's still, this still should have worked. So I'm not sure. I'm not sure why we didn't get more than one rock there. Light index. Nobody else indexes point lights. Why did we only get one? All right, time to license Unity. We officially don't know how to program anymore. Oh man, this iteration time is killing me. It is literally and figuratively killing me. So here's the thing. Okay, this is weird. So we still have a light here, and we have one here. This position is like the original position of the object. I am not sure. This could be like a bug in our iteration. It could be like anything, right? So like, wait, okay, first of all, rock, select all. There's two. These are them. Let me delete this one. Now it's that one. Like, what? Okay, first of all, no, no. Okay, the colors are coming out the same. They're always yellow. So if we had an alignment problem, we wouldn't have two yellow lights. So why do we have two yellow lights? Is our data not getting cleared correctly? No, because then... I'm sure the problem is simple, but it's a mystery. Does the index not get set back to 0? Well, it does every frame, and then we just put the rocks in. So what's happening right now is whichever one happens to get hit first by the iteration is casting the correct light. And then the other one has a wrong position. Like, okay, if I delete this one, then we get that one. It's wrong in the position. Why? That is so weird. It's got two lights. They're the correct color, but the position is wrong. What if I have a third one? Whoa. Now maybe we're just saturating to white, or just we're over. Dude, I don't know. Oh, we must be messing up the color. What if I just pad out the struct? I feel like we shouldn't have to pad out the struct. But like, let's pad it. Point light info, right? I think we have a zero array function that does all this, so you don't have to worry about getting it wrong. Anyway, that doesn't look like the problem to me. So here we have 4, no, that's light probe info. We have 4, 8, 9, and we're going to say pad is a vector 3. I don't think we should need that, because when we put these in an array, I think they're supposed to pad, but maybe they don't. Hey, look, it worked. All right, that's dealing with GPUs, ladies and gentlemen. All right, so like I guess our thing that checks for struct alignment only checks These are very intensely bright lights. It probably only checks the struct itself and not an array of that struct, right? So here we're going to turn the fighter's light down and make it red. And we're going to have these be yellow and subtler. And let's just see what we get. See, this is why you do it a step at a time. I thought, oh, that step's going to be too simple. But no, it wasn't too simple because we had a bug and we caught the bug. All right. Hey, look, our scene is more lively. Our scene is more lively. The yellow's a little weird. Let's make it a whitish yellow, because like yellow light like that is very kind of artificial, right? But if we make it like that. The scrape marks are baked into the terrain. No, they're not. No, we do. Oh, no. See these scrape marks here? Those are there because we played this level a bunch, right? If I undo, they go away. Do you think like we don't record the scrape marks in your save game state? What kind of a game do you think we're running here? Like, what are you even talking about? What kind of gaming stream do you think this is? Okay, so one reason this light looks so weird is we're not multiplying by the material color right now. Like it's just adding white light to the dude. It's not picking up the color of any of his stuff. So I think we want to try doing that Brdf function next and see what it looks like. And then I'm just going to leave this in the game for people to find. Actually, we don't want all rocks to glow. Like right now, I mean, there's a lot of rocks on this level, but we only really want the crystals. So for now, we'll approximate that by saying you know, later we'll deal. Like, I don't know if we're going to want these to glow, but it's kind of cool that they do, right? I mean, we'll run out eventually. So like here, they don't all glow because we ran out of light sources. Congratulations. Okay. Here we didn't though, and yeah, okay. Like that's cool, dude. Like, isn't that cool? Like that's just cool. Already the game's better. We don't even have shadows. We don't even use the Brdf. What kind of game doesn't store the scrape marks with your save game? It's true. What year do I think this game will be released? Well, clearly it's too good for 2019. I mean, come on. All right. So, what do we do now? You know, we could even see how the rock like tips like this. Before we do the Brdf stuff, I want to get that in. I don't think it's going to be a very big difference, but let's be in the habit of doing it. All right. So that's going to be, we're going to say relative pos is v3 0, 0.5. So it's just half a unit up into the cube. And we're going to say, this might actually not look as good, because right now the surfaces of the rock itself are kind of getting lit. We'll see. We'll see. Is object to world space. Wait, object to world. What's the visual version? Object to world visual. Faster object to world. No. Well, I know I have one. So that adds e dot position, which is not really what you want. Okay, well, we're going to do this the hard way. We're not going to worry about scale or anything yet, right? It's actually this orientation. So we do that. All right. We'll see if we can even see the difference when we tilt the rock. I mean, not really, but every little thing matters at some point. The light source, you can tell that it's coming from higher up, for sure. But it might have looked better from lower down. Right? Like, didn't the meshes like look less smooth? Exaggerate the movement? Nah, I don't want to do that. That's not where we're at. Like, these actually look better for this mesh. That's just a sort of thing, like, once we actually know what visual effects we're trying to do, then, yeah. Let's also, for the guy, see, this really intense red dot under him is basically because the light source is on the frickin' floor. So let's lift that up a little bit. That might be enough. Yeah, I mean, that's better. Still pretty weird. We still could probably stand to put it in him, but we'd probably want to mask his own light off of him, which we don't have the ability to do right now. We would decide that later. Anyway. It's pretty cool. Okay. What are we doing next? we are going to do that Brdf thing. Okay, so we need to pass some stuff to there that we don't have, right? So it's Brdf Unreal 4. We need a PBR. We need a shadow mask. That's just going to be 1 right now. Where's our evaluate? Okay, so we're going to need to pass this stuff. Okay. So here, we're going to do some things a little bit different, right? So we're going to get the direction. We might need some other stuff. And then we're going to call return Brdf Unreal 4 PBR 1. I guess L is supposed to point away. We'll see. And this, right? We're going to say vec3 result is this, return result. We could fiddle with result if we want. Oh, no, because we still want the distance squared. So we want this. These probably are fine. So it's probably just this. Uh-oh. Really? Oh, because we're not passing the PBR. Oh, no. Evaluate point light. Okay, so PBR, 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 PBR. All right. Now we're compiling. Around here, we only drink Pabst Blue Ribbon. We've been doing well. I think we deserve some more peppermint chocolate. Do we plan to use scrape marks in art to add a subtle hint? No. No, we don't. No hints. I mean, we might do it just as an aesthetic thing. Well, I mean, it looks like it worked. We're still getting light. It's a lot dimmer. Which you would expect when you're taking surface albedos into account. Let's crank that up. I don't know. We're making it brighter. We're making it brighter. Guy doesn't need to get that brighter. It's kind of weird. There's something else going on with the crystal shader that makes it darker in the corner. I don't know what that is, but it's not actually working. So we're not lighting the wall up for some reason. Do you see that? I mean, I feel like we're not lighting the wall up. Why not? We were before. Are we just not bright enough? Do we just have to frickin' crank it? Just make evaluate point light, return 100 times result. We'll wait for that to recompile, and then we'll see how sad we are. Yeah, like, it's not, I don't understand. Are like the normals backwards on all that stuff? Like everything else is fine. I think our materials are just really jacked and in bad ways, and nobody knows because like we don't have light sources. Like I think what's actually happening is that artists played around with materials to get the look that they want, which is not actually going to work because it doesn't make sense in the face of light sources. You know what I'm saying? Like, look at, or no, maybe it's not that. Maybe the normals are just wrong. Like this wasn't wrong before. Dude, is our, okay, maybe this Unreal thing is in a different space. Okay, hold on. This is a very clear case where I mean, like the rocks are a little too bright, but there's one. Like the material is definitely getting light, just not on that side of it. But the direction is correct. Like it's following this. Is that Pbr Unreal 4 thing just broken? Is that what's going on? It's just heinously broken and nobody ever noticed. Are you kidding me? Are you kidding me? I mean, I don't mean nobody in the world noticed. It's probably just our implementation has a bug. Maybe I'm calling it wrong? I don't think so, though. Like look, this is correct. Like, if my delta was minus in the wrong way, this wouldn't work, right? It's just with normals that point the wrong way. What if I use a different one? Like we have this Unreal 4. What if I use Pbr Mat? Oh, that needs this context thing. Oh God, that's like, yeah, totally different. All right. Let's see. Brdf foliage. Okay, we have Brdf mat that takes the same arguments. So let's try Brdf mat. as we compile. Well, that also doesn't work. It's very strange. It's definitely a different look. It's definitely tracking the object correctly. It just doesn't like... It's not even really aligned to the coordinates of the object. It's like literally, it doesn't like things that point along -x in world space. How does that even make any sense? So like if I drag this over here, it doesn't like things that point along -x in world space. Like, are you kidding me? It's quite possible I'm calling it incorrectly. It's also possible that that's not what's happening. I don't know. Like, if that is the problem, we would see it with the sun direction. Like if I delete this and that, and I find the sun, right? And I make it go way the other direction so that we're lighting things from -x. I mean, it looks like it's lighting them, right? So like maybe it legit is my problem. It's just a really weird problem. It's lighting them that way, it's lighting them that way. All right. What happens? What if I say point light direction is vec3 -100? That should be along the negative x-axis. And of course, we wait minutes to compile again. And we'll see. Do these point light values get put into an accumulator that's later getting nullified by sun shadow? Well, no, I mean, I deleted all the point lights right there, which is why we could see the sun, right? These are getting added in addition to sunlight, so no, sun shadow will not affect these at all. I mean, if things are working. Okay, well, I just said the point light direction is coming from -1, and that like didn't work. Wait, what? Okay, that means it's really probably my fault. Like I set it to this. Oh God, I set the delta. The delta is not going to be a unit vector, and the code may not expect that. All right. That was a mistake. I admit that was a mistake. And it didn't change anything. Well, maybe the PBR struct like has some stuff on it that like, I don't think it should. Oh, it's got like this backface factor already. That's not good. Do I need to init PBR for every light source? That could be what's happening. It could be that I'm dumb. Light independent parameters. Whoa, no. No, bro. This is supposed to be light independent parameters. So what is this here? What is all this? Those aren't light independent parameters. Oh, this is a to-do. This is not describing what it does. This is saying what we wish this did. Okay, so that's why this is all messed up, is because I was assuming that this PBR thing, like it looks like it's being passed around the code as like a constant thing, but it's actually got tons of stuff that's like hard-coded just for this light source. So we have to do something really ugly here. We have to call init PBR again. We have to find who does it before, and we have to do a different has lots of light dependent info in it, which the comment in init atop init PBR says is something to work on. So we need to do another one here. Ignore PBR. This should probably be cleaned up. Right. So this is going to be underscore PBR. Here, we're going to go here. We're going to go back to Unreal 4 instead of Mat because we now strongly suspect that this is the problem. I mean, it may not be the only problem. That's the nature of programming, but it's probably a problem. Okay, so context normal, we don't have the frickin' context. We're just going to say vertex normal because that's what we've been using. We're going to say point light direction. We need to pass this. All right, we need to pass this. All right. Okay. So we can now say ctx.whatever, base color, metalness, specular factor, all that stuff. Okay. Then we do the Brdf Unreal 4, but with direction, we're going to fix that. So Brdf is basically, it stands for bidirectional reflectance distribution function, and it just means how does this material respond to light as the light might come in from various directions and as you view that result from various directions. It's a spherical function that maps an incoming direction to an outgoing direction. Okay, point light direction, point light's index color RGB. I guess that's right. Who knows? Did we, I guess we saved that, and I mean, I guess, well, so now it's messed up, but in a different way. Great. Great. That's exactly, oh, because we passed the, no, we called this PBR. We called that PBR. Dude, see, at this point, I don't even know what's going into that PBR thing. It might be pulling other stuff that assumes sunlight. Like, I don't even know. Like, see here, it's tracking the light source. Sort of. But see, there's this n.l factor. It's, oh wait, is our -1 still in there? Wait, because it sure looks like it. Oh, that's what it looked like. There we go. I should have put a no check in on that. That's what happens when you do a thing and then you forget you did the thing. At this point, we totally need to license Unity. All right. There. Oh, look. Look how much sense this makes. Oh my God, it's so much better. All right. All right. Great. Great. Oh yeah. Oh yeah. All right. So let's reload this level. Whoops. That mesh doesn't look great now. I mean, I guess that's what the Unreal 4 is doing to it. Oh, because we cranked the brightness. Let's turn that back down. Yeah, 100. 100 is a lot. Let's try 10. Man. All this shader compilation, man. See, that's what graphics programming is like. It doesn't make sense. And then someday, if you're good, eventually it kind of makes sense, but it's still broken in some way that you don't notice yet. All right. I mean, you know, that's a thing. That's a thing. So the guy's light is obviously way too much. I don't know why. Maybe we'll put his around the middle. It's just too much on the floor, man. Look at that, though. Look at that. Our game has light in it. Now, sort of. Kinda. Okay, things are so much better now. All right. Let's take out this hack factor. We'll go back to our draw. We'll say we wanted this times 10. Let's just give it an even 10 on that. And let's make it a little more yellow. And for this guy, we don't want it that much brighter, but like that. And we'll just try putting it up in the middle of his square. We're still goofing around. All right. I'm going to work on startup times at work tomorrow because I don't know what's taking all this time. All right. So this is not the worst. It's not the best. It's fine. You know, it'll get tuned. Okay, so next step is you know what? While we're adding light sources, we'll just keep adding light sources. We're going to regret this, but we're just going to do this. We're going to add up to like 6. And where are we? Evaluate point light. Okay, and then we're going to make a new entity type. And for now, it's called point light. And, well, inner rate, and we won't mess with any of that. And K is it dot brightness. It dot. I guess we'll use the entity now. So we're going to want these point lights to have like various controls on them, like different functions that happen over time. And there's this field on the entity called the entity color that we probably want to use. And we'll just use that for now. Or it's called override color. We'll just use that for now. And later when we have an actual sim function for these, we'll make that happen. All right, so light.color and then light.color. We're just going to leave the alpha 1. We're going to multiply this color by K, the brightness. We'll get rid of the K. All right, so what is this entity? Well, it's a new thing. It's an entity point light. It's currently version 1. We're going to say that's just a temporary thing that we're going to do to test animating it, which we're not even doing yet. We're going to say brightness is 5. And that's really, we're going to add fields later. Oh, not entity, let's just say point light. We're going to add fields later. But this is probably enough. Now, when we make one of these in the editor, we want to set the default mesh, which is right where we are. And later we might make a custom mesh for it. But right now, we're going to set the mesh to, where's viewgiver? Viewgiver, okay. So this thing, it's just a little white sphere. Except it's not centered correctly, but that's fine. Okay, point light is going to get that mesh in the editor. Other things, we have to say when it is visible. Mode button. We have this thing for the sun. I just forget what the flag's called. Sun and world. Who looks at that? So these are the things we draw when this button is set. So point light is going to be one of those. This function only gets called in the editor. At other times than that, well, we go to here. So we're going to say point lights, they could move, they could change over time, but you can't see them. So you're going to put it here. Look at all our different entity types in our game. Thought it was a simple game, did you? Ha, ha, ha. All right. Well, let's see what happens. Wow, this startup time, dude. It wasn't this bad even like last week. Something happened. It might be something I did. I definitely added some things. Gonna have to time it. I'm putting startup time on this piece of paper, circling it 3 times, and putting little flares. All right, so if I go here and I say, oh, we have our sun thing, I can go point light and instantiate. And now I have a point light. Hey, we did all that today on stream. We did not have this capability at all. And now we do. Wait, oh. Our snapping logic is weird. We have to put that in. Right now it's being quantized to different squares. Okay, so let me turn that off, right? So, because it's hooked into our entity system, now we can be like, well, let's make it red. Let's make it a very bright red. Let's keep changing the color. Let's have a brown light, whatever that means. Let's go back to violet, right? So that's cool. Let's make another one. Let's make this one green and that one. Yeah, this is a good game. Now, see, you just do these things. When you do enough of them for long enough and you have a good game. That's basically how you make video games. If you're making your own engine. How do you foresee managing how much context get brought into the context struct in large projects? Okay, that context is different. That's not the programming language context. That's a GL rendering context. But no, because the GL context means a specific thing in GL. That's just like information for rendering a particular entity. It's not the same as like what you've seen on programming language demo streams. Okay, so now the way this works is the light sources are sort of priority 1, and then the objects, or then maybe the guy and then the objects, right? So we will run out of lights. Like if I keep making these, so now like, did we say 6? Yeah. So these aren't really shining anymore, you'll notice, and it's not really because it's being dominated by these lights, because for example, if I turn these intensities down to 0, we don't cull out things with 0 intensity, so they're still shining, actually, right? But if I delete one, now we've got space. If I delete another one, now we've got space for that one. And we'll figure out later what our light budget actually should be. But yeah, for now it is what it is. So now we have this ability that we did not have before, and that is nice. So now I think I'm going to heat up some more tea water, and then we'll start doing, like I made that strobing flag that we're not using yet. I'll use that to just animate the intensity over time, and that just means that we will have some sim loop running on these, right? And then we'll just probably add things to that loop over time, or we'll have it controlled in a data-driven way. This is just fun. We weren't able to do this at the start, and now we are. Now we are, because we program video games for a living. For a living, it's crazy. Okay, so yeah, we're gonna wanna edit some things, but it's all good. It's all good. $200. That's how bright. Our lights are so good we can make them 200. Okay. Can you make lights 200 in your engine? Probably yes, but you can also do it here. It's like you open the briefcase in Pulp Fiction. Would sparks or fireflies use this system, or are emissive particles done another way? Okay, here's the thing. There are different kinds of renderers. There are forward renderers, there are deferred renderers, there are forward plus renderers. They all have strengths and weaknesses, okay? The super weakness of the code that I typed so far on the stream is that we are paying, in terms of GPU heat and cycles, to do 6 light sources per pixel, even though we're only using like 4 right now. And in many scenes, we might not even use that much, or who knows how many we're going to use. Right now, if I want more light sources, which we will want, I just have to keep stamping out those lines. And that's eventually going to cost a lot, especially with all that Pbr init stuff that we're doing, and who knows. So, like there are different kinds of renderers that have different ways of working. So for example, a deferred renderer was supposed to save CPU because you could have like a localized light source, and if it only shines on some subset of pixels on the screen, you can do that in a post pass if you have like normal vectors for every pixel that you wrote. So deferred rendering was trendy for a while. The problem is if you're HDR, your light source probably touches most of the pixels in the scene anyway, so you don't really save very much with a deferred renderer. And it's expensive to make all those buffers and stuff. So people don't really do that anymore. I guess people do a thing called forward plus sometimes, but I'm not even sure what that is. So anyway, if we had lots of tiny light sources, or if we were doing light sources in a different way, you might be able to have some particles casting light. And maybe we should be daring and try that. So our array was 127 long, right? Now, if we did a prepass that said, for each entity, figure out which light sources are relevant to that entity, and then tell the shader those, and then only use those, then we might be able to have many more light sources. And then maybe there's a limit of like 6 light sources per entity or something, but you could have many more than 6 in the scene. And so if a lot of the light sources were small, they could affect things over here and not over there. Who knows? We're not doing that right now. It's non-trivial to do that, right? My goal for tonight is just to do some basics. Basics. See, I can have a light around the corner. Yeah, let me heat up some more water. Are there any other questions about what we have been doing so far? We're 2.5 hours into the stream, and we're already doing good. I'm also going to eat a banana. That's how well it's going. Why do light sources project shadows from the ambient light? I don't understand the question. From the ambient? What ambient? What? I don't get it. Please re-ask. You're starting to feel like Ignacio dislikes power of 2 minus 1 arrays as a general practice because it lets you fit the index in fewer bits. That could be true. I do not know. I do not know the reasoning. Will we do ray trace lights in this game? Not really, but well, I mean, we do have. Salvador was working on a fog volume that uses ray tracing, and that would probably use lights. It would probably trace the lights as well, I think. So we'll see. When writing a game engine, should the editor be part of the game executable, or should it be its own executable? In all the games I've ever done, it's part of the game executable, and I think that is very beneficial in a lot of ways. Yeah, I mean, as soon as you say that they are separate executables, you're taking a large degree of process hit that you can't get around. Whereas all the time, like if we're building levels, you know, I'm in the editor and then I hit F11 and I'm back in the game and I can play it. Like do not underestimate the power of that ability. It is very good. It is a very good ability. Bananas from Whole Foods are gross. Interesting display resolution, 3200 by 1800. That is not the display resolution. That is the resolution of the window that we are opening because we're not running in full screen mode. So it's saying display resolution, but that's how many pixels are in the window. Dude, why do I even buy fruit from Whole Foods, man? I don't understand. I mean, you know, they basically pick the bananas super raw and green in like Costa Rica or whatever, and then ship them up here for like a week because they have this massive distribution network. So like, they're just, I mean, if you've ever had a good banana, that's not what you get at Whole Foods anymore, sadly. Is it literally the only health food market around me? Well, I mean, I guess I could walk to Rainbow Grocery. That place is weird though, man. Do we have untyped int? Not really. What do you mean by that? Yeah, if I wanted to drive around town, there would be lots of places to go, but the Whole Foods is literally a 5-minute walk, but we've established I shouldn't buy fruit there. Okay. So here we're just calling a bunch of stuff. And it's not particularly organized, and that's fine. This is just a bunch of things that need to animate or whatever the game has to do, man. All right, so for manager by type dot point light, we're gonna do the stupid strobing thing that I did. If light dot strobing something else, light dot per frame output color is light dot override color. Okay, there we go. So we're going to say this. We're going to set color to this, and then we're going to do something with it. So we're just going to say CT is cosine manager.current time. CT times equals CT, so it's squared, so it goes between 0 and 1 and has sharper slants. And then color times equals CT, but color.w is 1. So we're doing that. We need to make this per frame output color. Per frame output color is a vector for no serialize. Okay. Now, another thing we can do while we're doing all this is when we go to draw, here, so first of all, we've got, oh, we forgot the brightness. Oh, don't forget that. And it's not brightness, it's light.brightness. All right, so here, get.per frame output color, okay? And then, I mean, we're not going to set this to 1 anymore. We're just going to trust that it's 1 in the per frame output color, or that if it's not 1, that whoever set it to not 1 knew what they were doing. Okay, and then there was one other thing I was going to remember to do. Oh! If not, we're just going to call this, right? If it's got a value of 0, we're just going to continue without increasing light index. Oh, we should do that before this. Actually, we should do that before all. This stuff, just because our theory was, yeah. So now, if we made a bunch of lights that happen to have intensity 0, oh geez. Color. See, this is an annoying error message because I don't actually say what the type is. That's going to be float 65. All right. So that's an error message that needs improvement. All right. We don't implicitly downcast double to float like you do in C. All right, so if I do this, I make a point light. Let's see if we broke it. We might have. I mean, doesn't appear to be doing anything. It really doesn't appear to be doing anything. Wait, why is that? What? Why is that showing up? Oh, I put this in a comment. That is not in a comment. That should be. So that is not our actual problem. But I was like, why can I see this in the editor? Now, what was weird was we didn't, I mean, maybe I should have left that whoops, not that. Point light. Make it. Okay, so I think this is just intensity 0. So like, if I make a bunch of these, I'm just pasting them. These aren't going out. So these are all getting rejected for having intensity 0 with that other code that I just did, right? So why? Oh, because it's override color. Right. Its override color is probably black. So let's go here. We can actually set this. Unlike certain programming languages, we can set members of our base class in our struct declaration. So we could say override. I can't do it to a struct literal yet, but I could do this like this. All right. So point light. That doesn't look any better. I'm disappointed. But why? So this, when I put this on, it's just blooming out the mesh. What did I do? Is this loop just not running? I broke it, people. Well, also though, why is this visible? It's not, like when we're not in sun mode, it's not supposed to be visible. There's all kinds of mysteries of the universe. Okay. So, I mean, let's whip out the debugger, I guess. All right. Okay. Oh, you know, I should have put an extra. All right, we'll see what happens. Point light, instantiate. Right? Right? Okay. I feel like we're just not hitting this code for some reason. I don't know why. We're totally not. Like, what? Oh, guys. This code only gets called during gameplay. This is a frickin' simulate function. What am I thinking? I am fired, okay? I am like fired. I am super fired. Somebody else better get ready to run this game company, because I sure can't do it, apparently. So let's just save this light into the level, and we'll be able to see it in the game. Look, it's there. Let's change the color. Let's make it strobing, actually. Let's see, and change the color to like Blood Dragon. Right? Look, it's an animated light source. So we actually do mostly know how to program. The problem is, mostly does not cut it in the big leagues, which is why I am fired. Mostly doesn't cut it. If you go up for your whiteboard interview, if you're a Hacker News guy and you go for the whiteboard interview at Google and they ask you, do you know what a binary tree is and how to link a node to another node? and you say, I mostly know how to link a node to another node, you're not even hired. You're out of there. Get back to the lobby. Get back to the lobby. Okay. It mostly works. So, we have an editor simulate function that we can call, but I don't believe that that function increments manager.currentTime. That's a gameplay thing. So we're going to say now. We're going to say now is this, but if manager for editing now is OS get time. Cast float. We'll put that down there. Actually, let's leave these doubles. Okay, so we're going to do that, and then I think it's called editor simulate. Simulate editor. There we go. Simulate editor. So promised lights are different from point lights. That's a whole other different issue. Update point lights manager. There we go. Now, who knows? Oh, it's not called OS get time. What? Just get time. All right. All right. We really could use some proto buffs in this game. Hey, look, I'm in the editor and I can still see the light source. What will they think of next? I literally cannot imagine what they will think of next. I could turn strobe off. Boop. Turn it on. So, you know, this would probably have a number of different functions about how a light might behave with some data parameters that control functions. Doom back in the day did this. And if Doom can do it, we can do it. But not tonight. I think we're just about done, people. This is what I had hoped to get done in the absolute best case by 2 a.m. And we're not even close to 2 a.m. Because, you know, you make mistakes, and sometimes it takes like 237 minutes to figure out your mistake. But not tonight. Okay. This has been good. So there's a couple things that I want to figure out. I want to figure out, why is this visible right now, even though we're not in frickin' sun mode? Okay. It's not visible in game, which is good, the actual sphere, right? But it is visible in the editor, and I'm not sure why. Sun and world, right? We did this thing. to make sure we didn't forget something. Okay, well, we return true if we're in sun and world. But what about... Ah, see, this is the trick. We got to do it again down here. Point light. We could really probably tighten this up a little. Okay, so that was that. And then the snapping. Who does the snapping? General 3D. Oh, we just sort of hard code it here. Okay, whatever. We're just going to do that. I mean, that could probably be better. Not Poipint light. That's why I'm fired. I think Poipint lights are a thing, which they obviously are not. All right. Look, it's not visible. Look, it's still not visible, but I click on the sun. It is visible. Now, I drag it around. It's not snapping to the grid. So I actually, whoops. I actually have control over where it goes. All right, our engine is now licensable on competitive terms. It's only $27,000 a day per seat. You can have this game engine. Call our biz guy to make a license. Seriously, if you want to pay that much, I'll totally send you this game tomorrow. But you have to pre-commit and pay for a year, because we can't just be tricked out of the source code for just one $27,000 fee. That's no good. Does the water get lit up by the point light? Well, right now this water is a temporary thing. It probably does, but it's just like a plane of a weird material down there. Yeah, see how it's getting kind of purple? But like water is going to be its whole different thing later. Well, we're winning. How long is a Mercurian year? We might actually do it for a Mercurian year. The Berkeley OCF still exists? What computers do they have in the OCF today? Are they like MacBooks or something? When I move the light sphere, there's a shadow on the ground. Okay, that's different. This shadow was just this mesh being rendered. You'll note if I go to the game, you do not see that shadow, right? It's because we're just drawing in the editor this mesh so that you have something to click on. We're also drawing the shadow, which actually helps you, because it helps you know in space where it is a little bit sometimes, right? So it's good. So if I turn this off, we don't draw the sphere anymore. You don't see that shadow. Now you could ask the question, why aren't we drawing shadows for these? And the answer is because someone flagged them do not cast shadow, either in the material or on the object, which is something we can do. I sort of feel like we shouldn't do that in general, but whatever. You know, if the shadow becomes a problem, we'll flag it, or if we want to be consistent, we'll flag it. How much of the stuff I wrote tonight is shipping with the compiler? 100% probably, although it'll probably get massaged into a pretty different form before we ship it. What is that 3-line circle symbol? I don't remember. It's like, it's something about, I think it's something about setting direction for these. No, I don't know. What is it? Oh, it's a fog plane. So this is our old fog system where there's a plane and we sort of like do some haze, right? The new system is going to be an actual volumetric thing. So this is going to be deprecated in favor of that. How much game creation specific stuff is shipping with the compiler? I mean, we're giving out a game engine. Like I've said that many times. It might not be out, because the game probably will be released a little bit after the compiler, or certainly after the compiler goes into beta. We may not give it all out initially, right? But when it's ready, we will provide the whole engine. That code where you square the cosine doesn't actually change the slope at all? What do you mean? Of course it does. I mean, it doesn't change. So the 0 crossings are in the same place, right? And the 1 crossings are in the same place. Well, they're not really crossings, but you know, you bounce off 0 and you bounce off 1, but the character of the curve in between is different, of course, right? So like the average slope doesn't change or whatever, right? But it gets like, I don't know. No, maybe that's not even a true statement. But the point is, it still has to get from 0 to 1 and back in the same amount of time, right? Just because you squared the value doesn't change that. Well, it used to go 0, -1, 0, 1, 0, -1, 0, 1, and now it goes 0, 1, 0, 0, 1, 0, 0, 1. But the values in between have changed, right? What does the big sphere do? This is a light probe that's used to just try to get better reflectance on all these things. Like, I wonder if I delete it. It doesn't really, well, yeah. Like, I'm not sure that it has a huge contribution to the scene right now. It might help when baking the light maps, though. I'm not really sure. But, like, if I delete the light probe, it's like, you know, stuff looks a little bit more dead. But, like, I think, you know, dynamic lights will add much more to the scene, right? But this helps. So basically, you render into a cube map, right? And then you use this when sampling all the objects. So if you have a scene with, like, a lot of light on one side of the scene, then you get a cube map that's like that, and that modifies, you know, the object during rendering. It just it does make for more believable scenes, right? So in this particular case, you know, it sort of captures the fact that we're open to the sky up here, somewhat, except that we have all these blocking things. No, really, the square of the cosine is congruent to cosine 2x divided by 2. Well, you're dividing by... Wait. Oh, I see. Dividing by 2. That's not true. Is it? No. Like... So the value that used to be 0.4 gets squared to 0.16. Maybe it is. Maybe it's one of these strange math facts. Certainly at well, yeah. I don't know. Yeah, okay. That's cool then. That's something that I assumed that isn't true about cosine. Probably it has something to do with sine squared x plus cosine squared x equals 1. Okay. Well, that's interesting. You need to cube it or higher to actually start changing the curvature. All right, well, not only did we do rendering, we have increased our math knowledge today. If you recall, I made other levels with the scene editor. Yeah, we have like hundreds of levels in this game. However, many of them are not like visually developed. Let me delete this and check it in again. Many of them are not visually developed to the same degree as this one. These are not levels that... Whoops, am I in the wrong cam? Why are my keep maps not working? Oh, because we're not... I see. I was just going to show off some other levels, but we aren't in the regular level set. We were in the special editor thing. So, you know, like a lot of these are, they're somewhat developed visuals that are not fully developed. Why do these crystals not look that lit? No, they are. It's just, they're not picking up the illumination themselves. This is an older crystal mesh that, like, I don't really think we're going to use. If we want the actual crystals to glow, we'll tune this stuff. Yeah, these meshes have a substantially different effect, where they don't pick the light up as much on their own. Whoa. Like, yeah, I don't know why. I guess that's what we get for having this many crystals. I don't know. Okay. There's more stuff that we could do, but I think it's Miller time. That's what I think. Must be processing some textures. Yeah. So, you know, these are all, you know, not, these were all designed by a designer external to the studio. And part of what this game is about is taking these levels and making graphically nice versions. But, you know, making a nice package. And if you add one before squaring, then it creates wonky curves, just as you expect. But you have to divide it by 4. You know, I'm starting to remember this now. Like, I think I actually knew somewhere deep down in my brain that this is how it behaves, but like I just kind of forgot. I knew this once upon a time. Anyway, we did good, man. We've got light sources. I'm going to leave them turned on the characters for now, for now. Even though that's not actually what we want long term in this way. We probably want different character colors. I could actually pick the override color from the character for those light sources, but are those set? Let's see. Let's see if we could do a last little thing. Yeah, it's set. It's set. Oh, that's going to be so easy. Let's try it. It's not quite brightness controlled, but yeah. Okay, so where were we? For each guy, see, this is like immediate mode. Like for each guy, we're not creating a point light entity and attaching it to the guy and trying to make sure that it's connected to him with a spring or something. We're just telling the GPU to draw a point light, right? So this is like immediate mode. In retained mode would be if we had to construct a point light entity and attach it to the guy. That would be like the Unity way of doing it, you know? Okay, so this is going to be override color. We're just making sure and we're going to multiply that by 10. Let's see what happens. Oh, that's very bright. Oh, look at that. Oh, Wizard, Mr. Wizard. This scene just gets wrecked. I don't quite know why. Again, it could be material properties or something. Oh my God. Look at the red and blue. It's so much. 10 in retrospect was a little bright. Oh my God. Get back to that 3-character one. So now really, we actually only want the, okay, so first of all, let's cut it way down. Secondly, do we have, see, we have active, but we don't have, let's just do this. Light T is a float, no serialize. So we're going to have this go up and down. Based on the active. So back here in sim, we don't want this to happen in the editor. we probably have another loop over the guys. Yeah, here. Okay, so if e.active, right, else, so if it's active, e.active t is moved towards, or no, light t1 by light rate times dt, and otherwise we go towards 0 and a little faster because it goes out faster than it comes up. I gotta stop starting on this level though, man. All right. Here we go. Switch. Oh, we're not using it. Duh. And the Warriors is just a little too dim, but whatever. Okay. Brightness, override times brightness times it.light2. You got to use it or you get fired. You have to use the variable. Why is the red light so much weaker than the blue light? First of all, like red is just, it's just weaker. That's the way RGB is set up. Like if you ever look at, there's basically a simple dot product that you do in order to compute the brightness of an RGB color. And you weigh red heavily, you weigh green less heavily, right? And it just, it has to do with, I guess, the way that eyes react to light and stuff, but also just the characteristics of that gamut, right? Like the shape of the colors. But also, it's just this guy, in addition to that phenomenon, this guy just has a less bright color. Like if you look at this, it's 72% saturation, 38% lightness. So like if we go here, if we compare to like the Thief, 91 saturation. I don't know how you know what that, this is like closer to the tip here, right? This guy is not. This guy, he's not really going to light anything up. So we might have to adjust that later, like, just have controlled intensities in a table somewhere or controlled light colors. Like, this is clearly not what we would like to ship, but it's kind of cool. It adds a little bit of life. So you could imagine dialing it to be more subtle, In fact, let's do that. Let's cut it in half. Which, well, not quite half. Thought you could change the stone light colors based on some status, player selection, crowding, etc. Yeah, I mean, there's lots of stuff we could do. Like maybe these crystals are kind of dim until you start moving them, and then they get bright for a little bit, and then they dim out again. There's all sorts of things you can imagine. All right, so here. Yeah, see, the red is really kind of, Okay. So this is cool. It adds to the game for sure. It's going to be so much cooler once we have shadows, because then like this guy teleports and you could have just like a big light at the teleport destination and like, and it like goes through the doorways and stuff. It's going to be cool. But here's a secret. Here's a secret that nobody else knows about me. I have never before in my entire life rendered to a cube map. I don't think. I believe that's the case. So like that's like a whole situation. All right. Thank you, everybody, for coming by. We did good stuff today. And that wasn't even our work day. We did a regular work day at work, and then we did this. And we had a lot of Bengal spice and some peppermint chocolate. It's been a really good day. So thank you, everybody, for being here for my really good day. And your really good day, hopefully. Let's see who we could visit.